morning. Good morning. Everybody have a good weekend. More water. Hold on. No sponsors. We're sponsored by Clear. It's just one of those clear days. True. It's brought to you by Raid Shadow Legends. That's right. Speaking of the performance task, several of you dorks have not emailed me. Where's it at? You guys don't email me a performance task in the next 9 seconds, I'm going to have Miss Lee come for you. All right, I have several, but still a handful that I don't have. Actually, I probably filtered all your guys' emails to the junk folder, so let me reconfigure that. Good morning. Please not again. You emailed it like 5 minutes ago. Okay. Grant, you think Grant? Actually, I don't think I got yours, so you might want to check again. At least I don't remember having it. RJ, yes, I remember getting yours. Try to send it through your phone. Gotcha. All right. Well, yeah. If you haven't gotten that to me, please do. Otherwise, oh, okay. Hold on. The bigger issue. How come nobody has been using the? How come nobody used the chat commands? What's going on here? Did you guys look at the title of the stream? No one's finding out all the cool info. All right, here we go. Here we go. All right, big news, guys. since I'm such a popular Twitch influencer, right, then Miss Shuri had me guest star on her YouTube video. So make sure to go watch that, like it, subscribe. Also, you can keep count of how many nerds that I beat in Connect 4. Called MC Escher cute. I don't want to talk about the video. Why is that a problem, Charlie? I don't understand. What is the issue? Please tell me. Objectively wrong. I don't think you know what objective means, but okay. Listen, if you're just upset that Miss Jury didn't invite you to be on her YouTube video, like, that's okay. I'm sure if you talk to her, that she'll let you one of these times. Also, happy birthday. Thanks. Appreciate it. Everybody virtually meet at Chuck E. Cheese later, okay? And we'll have a great time. I think it's sent this time. All right, I'll check it. I'll go through and respond to once I go and look at those. If I got yours, I'll just send you a quick like thanks, got it, or something like that after class, so you know that you or that I received it. All right. Well, in the meantime, so we have covered everything that could potentially be on the AP test. Question: do we get to do revisions? If you need to, like if you really get a score that is, you can't stand and want something more, then we can talk about that. But probably overall, I'm not going to be like correcting and sending it back to you, just because I don't know, just based on the amount of time that you had and sort of it was open notes and everything. So it's still a possibility, sure, but I'm not going to be like sending you back corrections of things to fix. Okay, but if I put in the scores and you're like, wow, no, I really don't like that, I want to do some corrections, then email me about it and we can talk. Cool. Hi, Mom. All right, so otherwise, we're just going to spend some time. We're going to kind of back off a little bit in terms of, well, definitely in terms of learning new stuff, right? But so we're just going to kind of practice various, mostly focusing, again, on FRQs, since that's what the AP test is going to look like. So this would be good kind of review, as well as practice looking at FRQs and how we answer those and everything. But separately, again, make sure to go through, look at that AP test review AFA. And it has lots of practice tests. So even though the multiple choice questions won't be part of it, right, still do the multiple choice questions because it's good practice, because those are skills that you're going to have to use in the FRQs. Okay, so check those out. Even if you're taking the BC test, look at the AB stuff, because you're still going to have to know how to do, all the units from AB are things that are eligible to be on BC as well, if that makes sense. So all the stuff that you hated from last semester could still potentially be on the test for BC. All right. The BC calc test is not just this semester's worth of learning. Okay. It's everything from AB plus then the new stuff we learned from BC. So still go back, look at AB stuff. All right. Look at those kind of summary or cheat sheets that are posted there to practice formulas. Look at there's like those links to like the flashcards and practice questions. Make your own flashcards and things, especially with formulas and things that you need to know. Just keep doing that in these next, 3 weeks, I think, until the AP test technically starts. The 11th, I guess a little over maybe. So in the meantime, my plan is that we'll do I don't know, at least for this week, my thought is we'll do 2 FRQs per day. Right, so I sent you this file from this first packet that's 4 questions. 1, 2, 3, 4. 4 different FRQs. So today we'll talk about 1 and 2. Tomorrow I'll talk about 3 and 4. Wednesday I'll send you out a new packet that will do 1 and 2. Then the next day 3 and 4. And then I'll send you a new packet and we'll do 1 and 2 and 3 and 4, etc. Okay, so 2 FRQs per day I think is pretty good. But so I know you didn't get this one until this morning, but for tomorrow, your homework tonight, besides just whatever studying or PFAs. God, you guys need to go do PFAs. Go do PFAs. Practice or try out these last 2 FRQs that we don't do in class together. That way we can, when we talk about them tomorrow in class, you can see what you got right, what you got wrong. I also sent you the scoring guides for those. Okay, so you technically have all the answers and the scoring guide, so you can see where all the points come from, so you can score yourself to see what you would have gotten if this had been the actual AP test question. So yeah. All right. Any questions for me before I start off here about performance task, about AP test, about review, about, I don't know, about anything? I guess not. Well, I don't know what happened. Okay, but I think I'm back. All right, so the summary is still nothing. Okay, well, then let's start off here. All right, so with number 1, I'm given a table of values from f prime, and f double prime. So I have the actual function, I have the first derivative, and I have the second derivative. And I know various values, but so this first column tells me some actual values of the functions. And then the subsequent columns tell me on these intervals what types of numbers are we getting. Are we getting positive values or negative values? Right. But then also between those, I do know actual values of the function. So f is a continuous function on 0 to 4. It's twice differentiable except at x equals 2. The function's derivatives have the properties indicated above. Great. Okay. So part A. For 0 to 4, right, for the interval x between 0 and 4, I guess is a little more clear, find all the values of x at which f has relative extremum. Determine whether f has a relative maximum or a relative minimum at each of these values. All right, so this is something that we talked a lot about during first semester. All right, so for extremum, or especially for determining relative mins or relative maxes, okay, then we should be looking at the derivative. Okay, this is basically the first derivative test, if you remember that from first semester. So we know that a maximum, that derivative will change from positive derivative to a negative derivative. A minimum will change from a negative derivative to a positive derivative. Okay, so for example, let's see. So I'm going to look at my f prime here. Okay, so positive. X equals 2. All right, so I see here that at x equals 2, my derivative changes. It was positive, but then it's negative, but then it changes to negative. All right, so that tells me there's a relative max at x equals 2. And as it says here, so justify your answer. Okay, so make sure if on a question you're told to justify your answer or explain or something like that, that you're providing evidence for how you know. Okay, so now for us, that can be something as simple as at x equal 2, f prime changes from positive to negative. Now, is there any relative minimum? So to be a relative minimum, the derivative would have to change from negative to positive. So this is the only spot where it says negative. Well, not the only spot, but it does not change from negative to positive. It goes from negative to negative again. Right? So that is not a relative minimum then. A relative minimum has to be that it's decreasing, negative derivative, and then positive derivative starts increasing. Right? Decreasing to increasing is a relative minimum. Increasing to decreasing is a relative maximum. All right, so there's part A. Part B, on the axes provided, sketch the graph of a function that has all the characteristics of f. Forget about the pink test booklet, whatever. But all right, so let's just do a quick sketch here. I'll go ahead and use this. I know it's kind of small, but I'll go ahead and use those axes to the right there. So let me first look at all my actual values that the problem gives me, right? I have actual points that I know. 0, -1, 1, 0, 2, 2, 3, 0. All right, so I'm going to go ahead and just put those points on my graph. All right, 0, -1, 1, 0, 2, 2, oops. Yeah, 2, 2, and 3, 0. All right, so that's just directly from those points that I saw, the points that I found. Okay, now I need to look at my derivatives to help me sketch out what this actually looks like. All right, so f prime, so between 0 to 1, so from my first 2 points, that red point to the most left and then the one next to it, the derivative is positive, which makes sense because it has to go up from one point to the other, so it should be increasing. So it makes sense the derivative is positive. But it also says that the second derivative should be negative. Okay, so we have to think back to what in the world does it mean? What does the second derivative mean? Right, well, if you remember, the second derivative helps determine for us if we are talking about a function that is concave up or concave down. All right, the concavity. So a second derivative that is negative means it will be concave down. So even though the function, or it is increasing, it's concave down. So it's kind of, all right, so for example, like this. It's increasing, but concave down. It's almost kind of like we can think about it as like opening downward. Okay, now for my next part, between 1 and 2, derivative is positive, which makes sense because it still should be going up to that next point. And second derivative is also positive. So this piece should be concave up. All right, so it kind of looks like this, where it's curved upward instead of downward. All right, next piece. First derivative is negative, so it's decreasing. Second derivative is also negative, so it's concave down. So it's decreasing and concave down. So something like this, where it's going down and is also kind of curving, opening downward. Right? I think this is just one of those connect the dots things where we end up with a shark. So I'm kind of excited about that. Right? Been watching a lot of scary movies lately, so I'm spooked. This is a special Halloween themed AP Calculus class. And then for my last section, from 3 to 4, negative first derivative, so decreasing, but positive second derivative, so concave up. All right, so it's going down, but concave up. So something like this. And we ruin the shark. But that has all the characteristics we need. This also makes sense to us. It should. I'm crying. RJ, why are you crying in the club right now? If I look at this point, we can see that, I don't know if you remember what this is called. It's called a cusp, right? Where those two kind of curves just meet at like a corner, like a point. It's a cusp. That makes sense then why these derivatives do not exist. Because remember, at a cusp or corner or asymptote, those derivatives will not exist. So this makes sense with our graph. Okay, part B. So part B was just sketch. Great. So I don't need to justify or anything. So part B, great, I did it. I'm a genius. He's a little dented, you know. He ran into some stuff. It's a metaphor. All right, part C. Let g be the function defined by g of x equals the integral of 1 to x f of t dt on the open interval 0 to 4. For 0 to 4, find all values of x at which g has a relative extremum. So extremum means max or min, so relative max or relative min. All right, determine which it is at each of these values. Justify your answer. All right, we can do that. So the first part that people get confused about is what in the hell is this saying? All right, people see this initially and kind of get a little worried. Right, all this is saying is that f is the derivative of g. Right, so it's like if you imagine this table had another row where g of x is up here. Right, so if we're thinking about g, then okay, f is the derivative of g, f prime is the second derivative of g, and f double prime is the third derivative of g. So it's just, that's all it's saying. Right? If we took the integral of f, we would get g. So conversely, if we took the derivative of g, we get f. All right, final values. What are we doing again? Oh, yes, that x has a relative maximum or a relative minimum. So if I'm trying to think of maxes or mins of g, well, how do we find relative maxes or mins? First derivative test, right? Where is the first derivative changing from positive to negative or negative to positive? Okay, well, so I'm just going to look at f now, since f is the derivative of g. So first of all, right, at x equals 1, the f is going from negative to positive, okay? So there's a relative minimum at x equals 1. And if we look, part C says justify your answer, so we need to give some explanation. That's fine. So relative min at x equals 1, since, what in the world? So I guess actually we could get away with saying since f changes, but let's be a little more specific. So since g prime, which is the same thing as f, changes from negative to positive, and then for relative max, that's not writing. There's a relative max at x equals, I thought I saw one, right? Yes. So at x equals 3, because it goes from positive to negative. So g prime, which is the same thing as f, right? F is the derivative of g, goes from positive to negative. So positive to negative indicates that there is a relative max. So at x equals 3. Wait, was that 3 or 2? 3, like I said. And then same explanation, same justification. Since g prime changes, but instead of from negative to positive, it is from positive to negative. So again, still using that first derivative test. Okay, so part D. For the function g, defined in part C, so we're still thinking about g, the integral of f, find all values at which g has a point of inflection and justify your answer. Okay, so a point of inflection, let's just think. So we're talking about a point of inflection for g. So that depends on when the concavity changes. So either when the second derivative goes positive to negative, or negative to positive. All right, so this, we wouldn't have to write this part. Well, we'll have to write justification. But this is just the idea of what an inflection point is, remembering, oh, yeah, that's when the concavity changes. It changes from concave down to concave up, or concave up to concave down. But the thing to remember is it's asking it about G. All right, it's not asking about F. So going back up to my table, so remember, F is the same thing as G prime. So that means F prime is the same thing as G double prime. So this is what I want to look at when I'm trying to determine, does G have an inflection point? I don't want to look at F double prime. F double prime would tell me, is there a point of inflection for F? But I want to think about G double prime since we're trying to find inflection points for G. All right, so here we have changes from positive to positive. Okay, nothing. But so I've circled this in so many colors, but I'm just going to keep circling it. Here we can see that the concavity goes from positive, concave up, to negative, concave down. So that is where our inflection point is at x equals 2. At x equals 2 is the inflection point because G prime changes from positive to negative, right? Or negative to positive. Positive to negative. Okay, any questions from this first one? This is mostly like that that AFA or PFA, like graphs of derivatives from first semester, right? It's just relating all the information of, okay, a function compared to its first derivative and its second derivative, and what does one thing mean for the other. I printed off like I gave you guys that summary page last semester that talks about a function, its derivative, and its second derivative, and what that means for everything, if it's positive or negative or changes, or how do we get inflection points or whatever. All right, let's go to 2. All right, so we have a graph of a function. We are told some various things. We know some of the points, right? Like, for example, we know -3, 1. We know 4, -2. We know these intercepts. We know this point. Now, the big thing to keep in mind is that this is the graph of f prime. Right? This is not the graph of f. So it's going to ask us questions about f, but we do not have the graph of f. We have the graph of f prime. Right? So it's a very common thing that you're not given the actual graph. You're given like the derivative or the integral of. Okay, so let's look at part A. Let's erase this. Part A. On what intervals, if any, is f increasing? Justify your answer. All right, so for f to be increasing, right, let's think about what does it mean. Since we have a graph of the derivative, if f is increasing, what does that mean for the derivatives? Right, well, it means the derivative is positive. Okay, great. So if I look at my graph, all I need to look for here is where is it positive? Right, which is this red segment here. Right, this is the only spot of this graph where the derivative is above the x-axis, right? Even though, so it kind of messes with your head. So even though the line is going down, but that piece is still above the x-axis, so it's positive, which means f is increasing. So f is increasing. Okay. On, let's say, -3 to -2. Let's write the interval to be more clear. And how do we know that? Since f prime is positive on that interval. All right, that one should be quick. Part B, find the x-coordinate of each point of inflection of the graph of f. So again, it's asking about f. It's not asking about f prime. So point of inflection. Now, what does that mean? Right, now, point of inflection we talked about from last time, right? Changes from concave up to concave down. Or another way to think about that is the second derivative is changing from positive to negative. Right? So this already gives me the graph of f prime. So let's look here. On this whole green piece, ， the second derivative would be negative because this is decreasing. Right, so I'm just thinking of the derivative of this line would be negative. Right, so f double prime is negative. Now for this piece, right, from here to here, even though it's below the x-axis, okay, if I looked at the derivative of this part of the curve, it would be positive because that piece is increasing throughout there. Okay, again, even though it's below the x-axis, even though we can kind of see that section is concave down, that's fine, but this part is increasing. So since the actual graph it shows us is the first derivative, then the derivative of this part would be the second derivative. All right, so that's positive. And then let's look at this third piece. So from here to here, it's going down, so that is decreasing. All right, so I should be able to see then I have 2 points of inflection. So we could say this in 2 ways. We could say f double prime changes from negative to positive. We could also say since f prime changes from decreasing to increasing, right? That's the same thing as saying the second derivative changes from negative to positive. So, or we could say, that green piece is decreasing, but then the orange piece is increasing. So f prime changes from decreasing to increasing. That's another way of saying it, but either way would fit. And then the other point, x equals 2, and I'll write it using the same wording just to be consistent. So since f prime changes from increasing to decreasing. Or another way that we could write that is since the second derivative of f changes from positive to negative. All right, part C. Find an equation for the line tangent to the graph of f at the point 0, 3. Okay. Equation of the line tangent to the graph at this point. Okay, so when I'm thinking about a tangent line, I'm thinking about a derivative. All right, so in order to create the equation of this line, I need my y minus y1 equals m times x minus x1, point slope form. Well, I already know the point, because it's telling me, right, it tells me from the very beginning, hey, this point is on the graph of f. Not the graph of f prime, but the graph of f. So this point is my x1, y1. So now I just need to figure out what is the slope. What is m? All right, well, we get slope by taking derivatives, right? So let's think about f prime of where? Well, where are we doing this? We're doing this at the x value 0. Right? That's what it tells us because it says find it at this point. So the x value of this point is 0. So that's what we're trying to find the slope at. So f prime of 0. How am I going to figure out f prime of 0? Well, I'm given a graph of f prime. All right, so let me just go up to this graph. And at 0, f prime is negative 2. Okay. So f prime of 0 is negative 2. Let's just now plug in everything we have. So remember, our x1, y1 is 0, 3. So y minus 3 equals negative 2 times x minus 0. Do some simplifying. Y equals negative 2x plus 3. This is the equation for the tangent line at x equals 0. Right, of f. We don't know what the graph of f looks like. We could sketch out kind of generally what it looks like, but this is for the graph of f. This is tangent. Tangent at x equals 0. You guys are so talkative today. I'm going to do this one on the next page so I don't have to scroll up and down. I can just go back and forth. So part D. Find f of negative 3 and f of 4. Question. Here we go. Is it a cusp for that last one at x equals 0? This point? This is a cusp, yes. True. It doesn't affect our problem. Like, we don't have to consider that for anything. But yeah, that's true. That is a cusp. What do you mean next question? Okay, yeah. Good. Okay, so f of negative 3 and f of 4. So when we have problems like this where, let me do some erasing here just to get rid of stuff. Visually cluttered. So when I see things like find a specific value, f of negative 3 and f of 4, but I'm only given the graph of the derivative, okay, this is a big clue to me that I'm going to be using the fundamental theorem of calculus. All right, now we've done setups for problems like this before, so let me show you how this actually works. Now, I forgot to actually do this one ahead of time, so we're going to do it live. So be careful with me. Make sure I'm not saying anything wrong. All right, so let's first look at f of negative 3. So I have to try to use the most information I can. So for example, I like that I know this value, right? This actual point. I know this actual point. And in addition to that, these areas, right, these parts that I shaded, I can figure out exactly what those areas are without doing an actual integral. Remember, an integral tells me area under a curve, but if I just can find, now that helps if I have a weird area, but these are just triangles. So if we need these areas to help us solve for something, we can use them because we know the area of a triangle, or at least I do. I paid attention to geometry, I think. I didn't do that, but I still know the formula. Okay, so let me set up just an expression that uses some of that information. So, and especially I want an expression that has f of -3 in it somewhere, since that's what I'm trying to find. Okay, so let's go f of 0 minus f of -3. And it has that f of -3 in it, which is what I want to find. So this to me looks like something from the fundamental theorem of calculus, so that's what I was saying before. So the fundamental theorem of calculus tells me, well, that's just anything of that format, right? That's just the same thing as the integral of whatever the derivative is. Right? Since f is since regular f is the integral of f prime, then this is basically what the fundamental theorem of calculus tells us, is that from the bounds, it's the antiderivative of the upper bound minus the antiderivative of the lower bound. Right? That's what we've been doing for months now. Okay, now how does this actually help me? Well, think about, again, what does this piece actually represent? What does an integral do? Well, this is the area under the curve between -3 and 0. I say under because of this section right here. All right, so it's technically the area above the curve, but it means the area between the curve and the x-axis. It's a more specific way to say it. Okay, well, what is that area? Well, let's look at this first triangle. Area of a triangle, you guys, 1/2 base times height. So that's 1/2. The base is 1. The height is 1. So, quick, RJ, what's 1/2 times 1 times 1? Oh, no. Okay. So, we have 1/2 there. And then the area of this triangle, so 1/2 base times height, that base is 2. Now the height, if I look at the height here, I'm going to put -2 because it goes down on the x-axis. And that actually makes sense. Right? If you remember, a negative area represents an area that's below the x-axis. So that does still make sense. For us, it is okay that we have negative areas here. So 1/2 times 2 times -2 is -2. right, so these are the two areas of those triangles. So this integral is just the first area plus the second area. It wouldn't let me type my answer. Oh, here. Well, that's okay. I'll let you try this one. 1/2 plus -2. I'll wait. I don't know why I'm still surprised that it's always in decimals, but I still always am. Okay, -3/2. So what we have is f of 0 minus f of 3 equals -3/2. Or -6/4. What? Remember, our whole goal here is we're trying to solve for this thing. So let's solve for this thing. So let's do some rearranging. F of 0 plus 3/2 equals f of -3. We know what f of 0 is because we are told what f of 0 is from the initial value of the problem. We know f of 0 is 3. Great. So 3 plus 3/2 equals f of -3. All right, so that would be 6/2 plus 3/2. We're running out of time, so I want to ask RJ. All right, and then the second part, asks what is f of 4? Okay, well, I'm going to do a similar thing. So this is just part B continued. So I want to create an expression that uses f of 4 in it, something that I can relate to the fundamental theorem of calculus. So it's always like a f of something minus f of something. So I'm going to do f of 4 minus f of 0. Now the fundamental theorem of calculus tells me that's the same thing as the integral of f prime from 0 to 4. Now, just like before, well, what does this actually represent? It represents the area under the curve from 0 to 4. So the area between the curve and the x-axis from 0 to 4. So I'm looking for this area. Now, these are not triangles, so I can't just immediately find the areas there, just do an area formula for those because I don't have one. But here's what I do know. Okay, so again, let me do some erasing just to clear some stuff up. Okay, here's what I do know. I do know that this is a rectangle. And I know that area is 8, right? Length times width. And the other thing that I know is that that curve not only looks like a semicircle, is actually a perfect semicircle. The problem tells me that. So yes, RJ, subtract the half circle thing from 8. Right. So the area of a circle is pi r squared. So we want to know, well, what's half of that? Okay, so the area of this section is half pi r squared, but the radius is 2. 1/2 pi r squared. 2 squared, 4. 4 times 1/2, 2. So 2 pi. And then, like RJ said, so this area, let's say orange. So that orange area is 8 minus 2 pi. Okay, but it should be negative. Oh, you can't see that. Right, 8 minus 2 pi is that orange area, but it should be negative because this is an area that's beneath the x-axis. So if this were all above the x-axis, then we would just say 8 minus 2 pi. But since it's below the x-axis, we will say negative quantity 8 minus 2 pi, or we could also write that as 2 pi minus 8. Okay, same thing. If you distribute the negative and then just swap the order. Okay, so let's call this 2 pi minus 8. F of 4 is the thing we're trying to find, minus f of 0. But wait a minute, that's something we already know. Right, we used that before. F of 0 is 3. So f of 4 equals 2 pi minus 8 plus 3. Two pi minus 5. So that is the actual value of f of 4. We don't have a function for f of 4. We don't have a graph for f of 4. But using the information that we knew previously, we're able to figure out what is the exact value of f of 4. All right, so using that fundamental theorem of calculus where I'm given information about a derivative, but I'm trying to find an exact value about the original function, well, maybe we can use the graph and maybe we'll figure out those areas to represent integrals and use some of the points that we started off knowing to help us solve for what those actual values are of the original function. All right. Sorry, I know we went a little bit over. Or wait. No, we're good. Never mind. I'm not sorry at all. Okay, so hopefully this was a good callback to some first derivative, second derivative stuff, as well as figuring out. We've done some of these problems before where we've had to use the fundamental theorem of calculus, so it's all about you being able to recognize that you need to create some sort of expression like this, since the problem asked us for these specific values, but we don't have a function and we can't take an integral because we don't have even a function for the derivative. We have a graph, we have some initial values, so let's use the fact that an integral actually represents area to then help us figure out the real values.